Hello everyone. Today we're going to look at two things: how to plot on the Mac using Swift and how to write an application that will work on both an iPad and on the Mac. And so we're going to combine both of these things. In scientific computing, we often have to display information. Now, Apple has this wonderful Playgrounds tool for mocking up code, and in it they give a very simple method of creating a plot. So if we import Darwin, we get access to all the standard functions like e to the x, sine of x, whatever. And we can let a function to equal line plot for x and all e to the minus x. We can choose a color, we can choose a line width, we can run our code, and we will display a plot of e to the x in a nice window, and we have access to all the tools. This seems like it's a very useful thing. We don't have to take random values. We could also select different ranges. So again, we have to import Darwin, let data equal XY data, and then we can populate this XY data array from values of -2 to 10 in steps of 0.2, and then create a line from the data set, line plot, and give it the XY data. We can set the color, set the line width, run my code. We get the same thing here, except with a specific range and a specific number of points. So this is really a nice feature that they have in Swift Playgrounds for learning how to code and how to mock up code. However, in their infinite wisdom, they don't give us access to this in the regular Swift programming environment in Xcode. So we don't have this simple line plot. This is a problem because especially students, we just want to be able to display a plot fairly easily. We're used to things like in Python where you have matplotlib. It's very easy to display something, and unfortunately it's not that easy to do in Swift from Xcode. So let's go ahead and start an Xcode project, and we're going to build the Mac application first so we can compare the difference between the Mac applications and applications that run both on the Mac and the iPad. So let's create a new project, and we'll select macOS app, and we'll call this SwiftPlot. We want to use storyboard, so everything else should be fine. And I'm just going to put it here. Now, in order to plot, because there's no default Swift plotting library, we have to use something by a third party. So we have to import third-party code. And what we have decided to use in my class is CorePlot. CorePlot is a 2D plotting code, open source. It is actually quite feature-rich. The downside to being feature-rich is it can often be complex to utilize. So if you want to use this in a simple way, it isn't always the easiest thing. And so in my class, we just are trying to get people to make simple plots to show the results that they've gotten from some calculation. I have actually written code to simplify that, and that's what I'm going to go to here. But in any case, you have to go to GitHub and download the CorePlot library. Now, when you go to CorePlot, you get the master branch right off the bat, the master branch almost never works. So you always want to go down to the latest release, which in this case is 2.4. And then you can hit the clone or download here. And it's just easy enough to download a zip file. I've already got this downloaded, so I'm not going to re-download it again, because given my internet speed, that might take 3 years. So I'll just show you from here on how to do this, but you'll have to download this for your own project. So if I come back to Xcode, I have my SwiftPlot, and then here I have my CorePlot release folder. And I have to look in here, and it's in the framework folder where I have the CorePlot Xcode project. And I just want to drag this into my SwiftPlot project, and it'll come in. Now, sometimes it takes a while to go ahead and index all the files. So this is a slow process, but that's all right. We can go ahead and let that happen. Now, as a cheat, I've added to this CorePlot folder a file that I'm going to add in. So if I go to CorePlot release 4, I have this shortcut.txt, and I can always add a text file to a project without damaging anything. And this basically down here has functions for plotting. And these are all the functions one would have to implement to make CorePlot display a plot in a window. And this is something that you could delve into and change a lot of things, but for a simple plotting application, it's not really necessary. And so what I do is I tend to copy this whole thing, go into my ViewController, and add it in. So if I look at this, let me go back to the shortcut.txt. I actually have all the normal view-did-load override things that are normally there. So I actually want to replace this whole thing. I do need to import Coco, so leave that. So now, by replacing this, I have imported CorePlot. It doesn't know what CorePlot is. We can fix that in a second. But my ViewController now is not just inheriting from the NS ViewController class, but it also now has to act as a data source for the scatter plot, and it has to act as a delegate for the CorePlot axis. Then we have a scatter graph that we're going to put in. We have to create a view for the plot and connect that. The plot data type is what holds the data for the scatter plot, and it needs data for the plot that has to be in here. So this little starting stub allows us to plot something. So if I go down here for the functions for plotting, I've written this make plot that takes a label for the x-axis, the y-axis, a minimum value for the x-axis, a maximum value for the x-axis for display, minimum value for the y-axis, minimum value for the x-axis. And so if we call make plot, it will display a plot with those parameters and those labels. And so I have simplified the use of CorePlot in great detail. Now the function that I call UpdatePlot, we'll have to have a button in our window that calls this. We have to connect that. But it populates the x-axis values, or the label values for the x-axis, y-axis, and all the min and max coordinates. And then I can create any x and y value and append them to the data that gets displayed in the plot. Then I call makePlot and run this plot. So let's go ahead and implement this in Storyboard. And I'm going to change this to make it a little bit bigger. I'm just going to make it 800 by 800. Drag that down there so I can see it. And then we're going to drag in two things. We're going to put a button that starts the calculation. And we'll call this display plot. And then over here we have to add a custom view. And that will hold our plot. Now we do need to change the type of the view to match that here in the view controller. So it has to be a CPT graph hosting view. Doesn't know about that yet, so if we want, we can come in here and make sure that we add the CorePlot framework. A framework is just a fancy name for a library if you're used to thinking about things in terms of libraries. So we'll add the CorePlot framework into this. So now it should know about CorePlot. Often takes a little bit of time for this error to go away. Sometimes we actually have to build it. And so I'm also going to copy this here, go back into storyboard, and I'm going to change the class from an NS view to a CPT graph hosting view. Now I can wire these two connections up. So I can connect my hosting view and I can connect my function. Now once I've done that, I can give it some value for what to calculate. So here I'll just say let x equal minus 2.0 plus double I times 0.2, and that'll give me a reasonable number of steps. And we'll let y be e to the minus x because that's what we wanted to plot, and we wanted to display e to the minus x. So we'll calculate the points of the function e to the minus x, add them to as xy points to the content array for display. All right, so this was a fairly short and simple program. Now if I build everything, so let me build CorePlot for the Mac to start. That succeeded. Now I can build SwiftPlot. SwiftPlot will build and run, we hope. And if I hit display plot, there we have a plot of e to the minus x. I can move the plot around. I can zoom in, zoom out, depending on what I want to do. So we have a simple program that will display a plot of e to the minus x. Now this will only run on the Mac, but I can create an application that I can give to anyone and have it run on the Mac. This looks like a Mac application. I can see that this is actually a button. It's very clear. So these are all good things. So I'm going to quit SwiftPlot here now that we've got it working. I'm going to do something else really quickly because Xcode has a feature that you can't have the code for a library in two projects at the same time. So we're going to create another project that will run on both an iPad and on the Mac using the Catalyst framework. But I can't have CorePlot open here, but I want to be able to display the two different applications simultaneously. So to do this, I'm going to go into here, Scheme. I'm going to edit my scheme, and I'm going to build a release version of the product. Turn off the ability to debug it because that will cause it to slow down. And now if I build this, I will get an application that I can run outside of Xcode. So it's the same project, perfect. But now if I go here, I have an application that I can show in the Finder. And I can double click on SwiftPlot and it will run. And so I have a useful application. Well, maybe not terribly useful because all it does is plot e to the minus x, but I can now use this to demonstrate the difference between a standard Mac app and a Catalyst plot app. All right, so I am now going to exit out of this project and we'll create a new project. Now this has to be an iOS app. It's going to be a single view app, and we'll call this Catalyst Plot. Now, because I want to run this on my iPad, I have to make sure that there is a signing team. Now, anyone can sign an app if you have a any kind of account with Apple. And so this is listed as a personal team because I'm using my personal iTunes account. So if you have an iTunes account, a .mac address, a .me, iCloud, whatever it is, you can get permission from Apple to sign these things, and then you can run them on the iPad or on any Mac. So we'll create Catalyst Plot. Now I have my iPad here connected to my computer using a USB-C to Lightning cable, and that allows me to see my iPad up in here. So iPad is there, so I can actually build and run this on my iPad. Now, this plotting program, in my opinion, doesn't work that well on the small screen of an iPhone. So I'm only going to make this work for an iPad and the Mac. So if I click on Mac, we now have to enable Mac support. It asks you, are you sure you want to do this? And the answer is yes, I want to do this. I want to build a Mac app. So now I can actually build it for my Mac, an iPad, and any of these other different types of iPads as well. Okay, so I want this because I don't think it works well in portrait mode, so I'm going to turn off portrait mode. I don't think we want to be able to run it upside down, so we'll make it landscape left or landscape right. So now we have to do the exact same thing that we did before. We have to drag CorePlot over into this application, bring it in there, and again, it's going to take some time to go ahead and bring everything in, figure out what all the files are. index everything. And so while we're waiting for that to happen up here, we can do the same thing we did before. We can add files to CorePlot, copy items if necessary, and we want to find, oh, and I moved it so I didn't copy it. That was kind of dumb. So I should copy it over from the other file. Yeah, that's the danger of this. Always copy items, don't move them. That's in SwiftPlot. Fortunately, I don't have to go too far to find it. I shouldn't have to go too far to find it. Oh, what happened there? Interesting. Where did that go? Just once, if something were easy. Now that I have Xcode in here, I can actually do this. So I'm going to open recent, and I'm going to open SwiftPlot. Find shortcut.txt. Seems like it is still there. Odd. Why wasn't it there before? No idea. Okay. There it is. Don't know why I didn't see it. But now I've got that added in, and I've added it to the wrong thing. Pull it down there. CorePlot accidentally. All right, so now we have shortcut. We can do the same thing here, except there's one problem. So now if I go to ViewController.Swift, my ViewController for this Catalyst app that works on both the Mac and the iPad isn't an NS ViewController anymore. It is a UI ViewController. So it's easier to just copy from here on down. And to paste from here. So now we have the same thing. I have a lot of other huge problems because it doesn't know CorePlot. So I'm going to import CorePlot, and we will add just as we did before, frameworks, libraries, and now we have to add CorePlot for iOS, and we want to make sure that it says macOS and iOS down here, and we want to make sure it says embed and sign because I do want it to actually work on the iPad. Okay. Again, we'll figure out why the error hasn't cleared yet, but we'll get to that point. So we can build CorePlot iOS, and I'm just going to build it for one of the iPad simulators. So I find it's always useful to build these things separately. All right, great. There we go. Yeah, usually building it will clear that error. So now we have to go into the storyboard. And we're viewing as an iPhone. Don't really want to view it as an iPhone. So I'm going to come back here to devices and pick the 7th generation iPad, picking that one because that's what I actually have this connected to. And we've already said up here that we want to support landscape modes. So we'll go back to storyboard, show it in landscape orientation, 7th generation iPad. And we can add the two things that we needed to add down here. We want to add a button. And if I come back to my SwiftPlot app, I can see that I called that button DisplayPlot. Put that there. And then we need our custom view. Unfortunately, in the UI kit that the iPad uses, there isn't a custom view anymore. It's just called a view. So we have to just drag over a view. We make that the size that we want. Okay. So now we have a view. We do have to change, just as we did before though, the class. It can't be a UI view anymore. It has to be a CPT graph hosting view. Alright, CPT graph hosting view. And then again, we can wire it up just as we did before. So we'll create our other window. That's good, I can see that. So I'll just change this window to be my So I can drag my hosting view over to my hosting view, and I can connect my function to my button. Close this up. And now, if we give it a function, and so we had this for minus 2.0 plus double.I times 0.2, so that'll give us the x coordinate. For the y component, we just want e to the minus x. Now we have our program wired up, and I'm going to build it here, catalyst plot, for one of the iPad simulators. So if I had build, I should end up with an iPad simulator running on my computer. And I now have an application that if I hit display plot, will plot e to the minus x, and I get everything that I would want. I can actually rotate the device and watch what happens, and it behaves as I would expect an iPad to actually operate, which is a good thing. And so I have good control, and I can play around with this on the iPad, launch the app. But if we look carefully, it's got a default icon that looks terrible, and we'll address that. But the simulator is actually fairly nice. I'm going to stop the simulator, stop it running from there. Now I'm going to build it for my Mac and see what happens. Interesting. Could not build Objective-C module CorePlot. interesting because it fired up Catalyst Plot anyway. Oh, I love computers. And it works. So I have no idea what that lovely message was, but it is what it is. If computers ever behaved as one would expect, so I can move this around, I can zoom. The problem is this button. DisplayPlot doesn't look like a button, it looks like a piece of text. This is one of the big differences between these Mac apps that are made for the Mac directly and these iPad apps that are really created for the iPad and moved over for the Mac. So one of the things we should really do, because it is nice to be able to have something that runs on all of these devices simultaneously, is improve the functionality a little bit. And we can actually do that. Now that was a really interesting error message. I love all these fun error messages. But all right, so how are we going to make this a little bit better and a little bit more Mac-like? Well, one of the things we can do is to give it some indication that that's a button when we hover over it. So to do this, we actually have to add something. So I'm going to come back over here. I'm going to show our storyboard. And I'm going to find our button, and I'm going to connect our button as an outlet. So I'm going to say this is our button. And I should use a better name. Could change it later if I wanted to. But now we have a button that's a user interface button. So now I'm going to create another function here. And so we're going to make a function that basically is acting as an Objective-C-like function, so we have to give it the Objective-C handle at Objective-C. We're going to call it hovering. And so we're going to go UI hover gesture recognizer. And so this will recognize when we are hovering over the button. When we're hovering over the button, we want it to actually change the button. So we're going to switch based on the recognizer state. And if it is began or changed, then we are going to make it button.title label text color equals number color literal red color literal what in the world is going on there? No idea why that's happening. Okay, let me cheat. I'm going to comment that out while I type the whole thing. Color literal, red 1.0, green 1.0, blue 1. So blue 0, green 0, and we'll set the alpha channel to be 1.0. I'm going to close that. Then I am going, so this should make a color red. No, oh yeah, I missed a comma in there. Okay, there we go, and now it gives me a text color red. This is something I don't really care for. And again, this is my own trick with dealing with these stupid color literals. I guess it's nice that you can see what color it is, but if I want to change anything, I comment it out and change it, and so I can make a different color, green, uncommented, and then so that's yellow, whatever. But this is my trick to working with these things because I don't think that it's quite ready for prime time. But everybody, I'm sure, has their own workaround for using these things. All right, now default. We'll break and get out of this thing. And then we need another case for when we're done hovering, which is ended. And then we'll just make this the default color. And the standard color is the UI color dot link. Okay. Now equals UI color dot link. There we go. All right, then we still have to let the button know that it actually interacts with this. So if we go into view did load, we can type let hover equal UI hover gesture recognizer target will be self, because that's where I have the function. And the selector will be hovering. And we have to give it underscore colon. And I gotta make sure I have all these closed. That looks like I probably still missing. Okay. Oh, yeah, that's it. That's it. Okay, you got to give it the selector. Okay, so now that should, yeah, I don't want to fix that because now that I have my hover gesture, then I'm going to go to my button and add gesture recognizer hover. So now I've used it. Perfect. So now let's rebuild this for the Mac. And now when I hover over the display plot button, it turns red. So at least I know that that thing isn't just a text label and it actually does something. So if I hover over it, I can change the plot, go back, zoom in, zoom out, move it around, come back here. So that at least tells me this isn't just some broken button of text that sits there. So that's a good thing. It isn't completely Mac-like, but at least, because that I can clearly identify as a button in the SwiftPlot, whereas it still looks like text hanging on the screen, but at least if I mouse over it, I now get some sort of an indication that it does something, that something has changed with that. Now that's good. So I also want to show you that this will run on my iPad. But before I dump this thing onto my iPad, I want to do something else. So if I come back up here to the Catalyst plot, I can see here app icons and launch images. And if I click on here, I can see that I am missing any icons. Now I have created icons elsewhere, and I'm going to add them in. So I'm going to add files, Catalyst plot, copy items if needed, and I've got these in my download folder. And so I've created little icons at many of these resolutions. I'm going to copy them over, and it would have been nice if I would have copied them over into the right spot. Move them down into there, into the Catalyst plot. Now, because these are part of my project, I can actually add them as icon sources. And so I can drag them in to the ones that need this. 76, 80, 40, 29, 58. Oh, that's the iPhone. So because we didn't build this for an iPhone, don't need these. But now we've got all the iPad ones set up. Now I could actually build this app and put it onto my iPad. Now the easiest way to show my iPad screen is to use QuickTime Player. And this doesn't always work, so I'm going to build it for my iPad first so I know I get it onto my iPad. Because unfortunately sometimes Xcode and the QuickTime don't behave as nicely as they could. So now that I've got it built, come out here, I'll go File, New Movie Recording. So this is a cheat to get your iPad onto your screen. I'm going to tell it to stop recording. But here we can see that I have my app Catalyst plot. And this is my iPad, so yeah, that's bad. Yeah, don't change the order of the orientation of the iPad when you're doing that, because it cancels. So it's lost connection to my iPad because I did pull it up, but that's okay. Because again, it's already built in on my iPad, so let's bring this back again. Oh, notifications are still going, even though I asked it to turn that off. But here I can see my iPad, move it around, show you what's on my iPad. I hit Catalyst plot, and there's my application running on the iPad. So I can hit display plot, I can zoom, I can move it around exactly as we want. And so this is actually moving and operating on my iPad. So now we have an application that will plot something on the Mac, on the iPad, will run on both. So let me go ahead and kill this, come back over here, put that down. And we'll go back, build this again for my Mac. Yeah, stop that instance. And now it actually has the application for the Mac, or the icon for the Mac instead of the generic icon that SwiftPlot has down here. And again, it works. It allows you to use the same code, but on the other hand, you can clearly see that it's not exactly a standard, well-polished Mac app. But if you're going to write something that will run on both the iPad and on the Mac, using this Catalyst environment is actually fairly useful. It does give you results that work. It gives you useful results, but it's worth spending a little extra time so it's not just a brain dead copy on the iPad to the Mac. Make it a little bit more Mac-like by at least indicating that some of these things are actually buttons and not just random text. So with that, I hope you've learned how to do something a little different. The plotting, not always the easiest thing to do. It would be nice if Apple just released a plotting library of their own, like they did for the Swift Playgrounds, which is really more of an educational type environment. But we can't control what Apple does, is going to do, or will ever do, because they're all smarter than us. Maybe they're planning on bypassing our eyes for the next iDevice that they release, and it'll just beam information to our brains so we actually don't have to see presentations. But until they come up with something, we do have CorePlot. It works, even though it may be a little bit more complicated. But again, you're free to use these little code bases that I put together to make it easier to plot on the Mac. I will be posting this to GitHub myself, so everybody can download these from there and check them out. So with that, thanks for watching, and see you next time.